So, today we are going to be talking about. Can someone change the?
Alright, who do I have in here that's interested in electrical engineering in college?
Woo!
Most of you have it on your website, so I know. What about the yes?
Hey, what is what?
Where are my mechanical engineers at?
Biomedical engineering? Civil engineering?
I tried.
Environmental engineering?
Wait, computer engineering.
That's
Two people for that.
Alright, so, meet the engineers. Today we are going to be talking about the different majors in engineering. In the different various fields of engineering. Whether it's aerospace, or I'm going to talk big around some aerospace. Mechanical, computer engineering, electrical engineering, I'm forgetting some.
Computer engineering. All the engineering.
Nano engineering. We're going to talk about all those different fields of engineering today, and the differences between them, and what you do when you major in that in your whatever college you go to, if you choose to follow that path. So, I'm assuming that all you guys are. So, yeah, that's what we're going to be talking about today. What each field actually does. Like, a lot of you guys don't really know. A lot of you don't know the difference between computer science or computer engineering, and like. I know that's a big one. Computer science, computer engineering, and electrical engineering. Those three, a lot of people kind of mix them up and don't really know where one ends and the other begins. Or in reality, it is pretty blurred boundaries, but there are differences in what you choose and what you want to do in those fields. So that's what we're going to be talking about today.
Gosh, put your phones away.
Alright, so we're going to start with mechanical engineering, and we're going to call over to Barshi, Eduardo, Rich.
The four of us are all, at some point, took mechanical engineering. I know you guys, I don't know if you did it for a master's or undergrad. Undergrad, okay. But yeah, so mechanical engineering is kind of what you probably think of most of the time when you think of engineering. It's such a broad field. There's really so many different things that you can do with it. So we thought we'd just kind of go and talk to you about what each of us does with it. And remember, this is just a very small sample of what you can really do with mechanical engineering. So does anyone kind of want to start with theirs?
Sure, I'll just start with a very broad overview.
Okay.
So you can kind of think of mechanical engineering as engineering things that move. This could be cars, this could be boats, this could be planes, and the design behind that, whether it's airfoils, or wheels, or fluids. In school I worked a lot on sailboats. I thought those were really neat. If you think of a sailboat, it's actually a sideways airplane with two different fluids, so it's a really neat challenge.
Yeah, so I just completed my first year in mechanical engineering, and pretty much what I've gone over is mainly some intro to manufacturing and material science. That's also a big thing in mechanical engineering, and then next year I'm taking more courses in CAD. So CAD is a big software. Many of you guys will probably use it for your modifications, and with that you can 3D print and use a CNC machine here at BlueStamp, and there's so many good uses for it.
There's also thermodynamics in mechanical engineering that you work with a lot. This also has some overlap with chemical engineering. Hopefully we're talking about that later.
Yeah. I'm not sure if we have any chemical engineers, but
we can talk about it.
yeah. Yeah, and then within college, so I'm also a rising sophomore, and so there's a lot of things that you can do as a mechanical engineer in school. So one thing I think a lot of schools have, I have an example here, is something, Formula SAE. SAE is Society of Automotive Engineers. There's a lot of programs that are similar to this, and it brings together a lot of different disciplines of engineers, but you'll largely find mechanical engineers. Pretty much everything you see here was designed and built by mechanical engineers. There's electrical systems within the car that are made by electrical engineers, but pretty much the majority of this is a mechanical engineering project. So there's a lot of ways that you can kind of apply yourself in mechanical engineering, whether it is, understanding things like suspension mechanisms or aerodynamics. For me, my personal experience, I have taken some statics classes, some CAD classes, but we'll be going more in depth with mechanical systems and fluids this coming year.
Alright, so for those of you that don't know, my name is Eduardo.
Eduardo.
I'm a master's student, so I finished my undergrad in a different field, which I'll talk about later. And then also, I may not have as much experience as most of these people, or at least as much as I know. I'm in my second year in my program right now. Hopefully, I'll be done within the next year or so. I can tell you about projects that I did there with ASME, like Rich said. There's different organizations, the American Society of Mechanical Engineers. It's a big organization nationwide, and some of the projects, or the project that I worked on was the student design project, where it's a regional and then national competition, where a team of students design and build a robot that does a specific task. So I guess more or less it's in the mechatronics field, which most of you are somewhat familiar with, at least a little bit right now. And that's pretty much all I've done so far. Class-wise, I'm pretty much taking the same classes they are. I'm just going a little bit more in depth with regards to a lot of the simplifications for them are like one-dimensional, two-dimensional systems, and then maybe Laura's seen it. Later on, you can get to three-dimensional systems, and it just gets really complicated from there. But that's pretty much me for mechanical engineering.
Yeah.
Are we doing a bit on civil engineering as well, or do we not have that?
I don't know if, I mean,
Okay, does anyone know what civil engineering is here? Army!
Vaguely, kind of like for the city, or like...
Yeah, exactly. So you can think, I feel like when I was giving college tours of my campus, we would get a lot of questions about the difference between civil engineering and mechanical engineering. And civil engineering is like the design of cities, buildings, all that stuff. But let's see, this should be familiar to a lot of you.
urban planning, right? And, yeah, statics.
F equals MA. So in civil engineering, you always want to see 1 0. In mechanical engineering, the difference is that sometimes this can equal something. I don't want to put, this is usually non-zero, unless you're working on design of things or fatigue of things. So that's kind of how I like to explain it. Civil engineering, you want nothing to be moving. Mechanical engineering, a lot of the time you're working with things that are moving and have to withstand fatigue or repeated motion, that sort of design.
Do we want to do questions after each?
Yeah, I think
Okay.
after each.
So, yeah, so,
We can do it after.
well,
No, I
I'm
didn't
saying,
say
after each.
So, like, your
discussion,
questions,
yeah,
yeah.
we'll all
Yeah.
fresh in their mind. Does anyone have any questions about mechanical engineering?
Does anyone want to know like what kind of clubs there are in particular in mechanical engineering, or that works with them?
Army!
Rohan had it up. Wait, no, never mind. Don't worry about it.
Do you know about more clubs?
Yeah.
Okay, in college or in high school?
Oh.
Okay, awesome. So I think I talked to my team, my class a little bit about this. In college, engineers can do sports, but what's cooler than sports for engineers is something called project teams. So depending on the school you go to, most will have a lot of these same ones. Project teams are engineering sports in the way that you're working with a group of people. It could be electrical, mechanical, CS, to design something. So this could be a drone that flies, or a submarine drone, or a sailboat, or a race car, or an electric motorcycle. So that's what I would definitely encourage you guys to do. I think it's great, it's very fulfilling, it also takes up a lot of your time, but it's fantastic. Those are kind of the most basic ones and the most popular ones because you compete in competitions, you build cool things, you can build rockets, Mars rovers. Other things are ASME.
Yes, yeah.
Do you want to talk about that?
Oh yeah, sure. So as I said, ASME is a national organization, and I think it also goes into the professional level. I'm actually 100% positive it does. ASME, again, there's multiple projects, and like Laura said, it's a combination of mechanical, electrical, computer science, because no one student in one specific field can do a project. And I mean, you saw that you've seen it with some of the presenters that come in, that they have teams of like 20 people, 30 people, or even a whole company that might be working on one project. Specifically, they do human-powered vehicle, they do the student design project, they do, I'm trying to remember some of the other ones.
Research. There's also research
Yes.
teams at all of your universities. Your different professors are professors, but also a lot of their main focus is research. So if you get good grades, they'll take you to do research with them. That can be on things like thermodynamics, fluid mechanics, normal mechanics, biomedical engineering. So those are other venues that you can get from college. There's also clubs and whatever personal projects you choose to do yourself. Those can be a little specific to the college you go to. So a great college question, if you're on a tour: what kind of clubs do you guys have for so-and-so? Or what kind of opportunities do you have for this field?
Any other questions for mechanical engineering?
Another big thing is like as a mechanical engineer, like if you guys really like are into building, that's building and design. You say like when you were a kid, like for me, I was really into Legos, and with that, growing up going from Legos to now machining parts and other things. You can also look in your colleges that when you're choosing between one over another, how big are their like do they call it maker spaces?
Yeah.
Labs or build labs. You want to see like does one university have one and another one doesn't?
Are they led by students? Can you join those labs? How hard is it to do that? Yeah, so definitely great questions to think about for your college tours and considerations. Any other questions? All right, maybe move on.
Alright, so computer science, and I put a / software engineering, because they're both kind of this, when you major in computer science, you can then go into software engineering or go into actual computer science, which I'm going to get to in a second. So what we're going to be talking about is when you major in computer science, there's two different directions you can go in. You can either go into like the more scientist route and do research in the lab, or you could go into like the industry and go into software engineering, which is what we do more here, which is software engineering and building and designing software. So it's when you're going to see when you get to college and you start majoring in computer science, you're going to see that there's usually kind of like two types of computer science majors. There's the people who want to go and work in research and labs and kind of like discover new interesting mathematical like formulas, like make really efficient algorithms that do really cool things and all that, but like are not necessarily being applied in industry at the very moment. And then you're going to see people who want to go out and build an app, and that's going to get really popular and it's going to blow up and be amazing. Those are two different types of those are two parts of the same major. When you major in computer science, it allows you to go out and do build an efficient app that works well and it doesn't freeze up and all that. It teaches you how to program. It teaches you the theory behind computer science that allows you to go out and build these things.
Yeah, adding on to that, I would say it's not even like two different branches. There's like so much stuff you can do in CS, like so many different things. I know like where I go to school, there's like classes you can find on everything from the software engineering aspect, more of like building apps and stuff. You could do theory, so like a lot of the theory actually is very philosophical. So like stuff like are certain problems even solvable? So you do problems, it's called P equals NP. I mean, you don't have to worry about it, it's pretty mind-boggling stuff, but like the gist of it is like there's so much stuff that you may never have even imagined is actually CS. Because I know a lot of people when they think about CS, they just think about code, writing code, but it's a lot more than that. There's a lot of theory that goes into it. There's a lot of stuff with algorithms as well. I think that's what Chris mentioned as well, that goes into it as well. So you can study all sorts of data structures, like lists, and there's a lot of stuff. So CS is kind of a broad term for a lot of different things. If you're interested in any one of those things, CS is for you.
Yeah, and I just wanted to briefly also mention that he just mentioned it briefly, but two of the most important courses I've taken as a career science, not that I've taken, I still take algorithms, but two very, very, very important courses you're going to take as a computer science major are data structures and algorithms. Those two will make you basically a better programmer by understanding the tools that you have and how to create your own tools to allow you to do what you need to do, and how to solve problems and do all that sort of stuff. How to basically just think as a programmer. Data structures are for those who have coded before, a data structure is something like a list or an array or a queue or something like that. There's also trees and maps and the list goes on.
That's a tree over there.
It's a form of a tree actually, not really. That's
I put a tree.
Oh, yeah, that's good job. Right here is a tree. It's there. That's a tree right there. I didn't see that there. Yeah. So this is a tree right here, and it's basically like one way of representing data and like working with it. And the whole idea behind like what you learn to do is how to build these structures, like these sort of abstract structures, and like be able to implement them in solid ways in your code. Yeah.
Yeah, also a lot of mathematics was involved and computer science, like one of the most useful courses I took was like a proof-based math course. And it teaches you how to think in a different way. And you get to see how math applies to computer science as well. It's more theoretical. Yeah, and I know like I didn't see a lot of hands for EE, but like I know when I was applying to college, like EE was like up there for me as well. So I was like really deciding between CS and EE because I really love EE as well. And it turns out if you're electrical engineering, yeah, sorry. And if it turns out that if you do CS, you end up, at least I think for most schools, you end up taking a lot of EE classes as well to actually get the CS major. So if you're someone who likes EE, also likes CS, if you do CS, you will end up taking EE classes as well. I don't know if that's something you guys want to do or not, but I think that for me that was a bonus. So we have a question.
What about EECS?
Yes, I know.
So
like
for computer engineering, it's kind of like in between, but look at we'll talk about.
Yeah. No,
I'm going to. I think what I'll do is I'll help differentiate. I'll start the differentiation between CS and computer engineering, and look at you can talk about the differentiation between computer engineering and electrical engineering. Yeah, and then like.
Yeah, my slide's empty. It's okay.
Not anymore.
Not anymore. It's not empty.
What do you guys put up there?
No worries. You'll see. Yeah. All right.
We went through the paper.
Alright guys, pay attention!
So to answer your question though, you were basically saying like what about EECS, like EECS? So there are certain schools like Berkeley, for example. I know Berkeley has an EECS program, so it's EE and CS together. I'm just a CS major, but even as a CS major, I have to take EE classes on top of that.
Yeah, so with CS, a lot of the time, CS is great and there's so much to learn about it, but a lot of the time you'll do CS, but you have to take a certain amount of classes outside of it to have like CS and then a focus in something. So that can let you do your side interest.
I will say it's definitely school by school. At least the one that I went to, there's two different schools. There's the engineering school and then there's everything else. And you can do CS in either of them.
Yep.
So if you do CS in the non-engineering school, you're not going to get any of the EE stuff. Whereas if you do CS in the engineering school, you take one intro to EE, but then that's it. Where if you wanted to do more, like you kind of go with your engineering route.
So it wasn't a requirement then.
Right. So it depends on the school.
Yeah, it depends on the school, but I think a lot of schools nowadays do make you do EE. But yeah, it's up to the school.
Yeah, and in fact, I'm doing computer science in Cornell's College of Arts and Science, and so there's the College of Arts and Science and the College of Engineering, which is a very similar format that Ash just mentioned. I'm doing it in the Arts and Science school, so I'm getting a Bachelor in Arts rather than a Bachelor in Science, but I'm still taking, by my own choice, like I'm going to be taking a lot of like EE courses, just because I want to learn that material. So like, as Asher mentioned, it's very dependent on the school you go to, because if school allows you more freedom in the courses that you take, you can do that. Or if sometimes the school just has it that you have to take those courses, and that's also fine, then you take those courses and you learn about that.
Well, that's good questions to ask on that college tour. Is your computer science program in the engineering school or in the humanities or arts and sciences school?
Also, you should check with how many electives you're allowed, because you can choose subjects which are not related to your major but you're interested in studying. So you should really check up on how many electives you're allowed throughout your duration at school. So that's also one thing you should check up on.
Yeah, definitely. Yeah, and I just wanted to briefly touch on something else. Yeah, so the difference between computer science and computer engineering. So computer science is purely about, not purely, but mostly about software. Like, that's the main focus of computer science. You're working with how a computer reads and understands code, and how does it process that and work with that. But now this can be as high level as like Java, where like and C++, where like you're writing code that looks like words, and then it gets compiled and understood by a computer, and performs those actions. You also work with you also work with compilers, like having it so they can actually take this code. Like, how does the computer take this code, these words, break it down to something it understands, and then run it? Like, how does it do that? That's what computer scientists, that's what computer science majors kind of look into and work on and create their own. In fact, there's a course called compilers, you can take that. There's also a course called programming languages, you can take that. So there's all these different courses about all these different little topics, but it's all about software.
Yeah, and in software engineering, there's like different type of developer, like a full stack developer knows both front end and back end. So you got some experience with WordPress, so you can see like more of the front end stuff, which is.
Front end and back end. Yeah. So.
What is it?
We have about 5 minutes left until lunch.
Yeah.
So
Yeah, let's try to move this
Yeah,
on.
let's
so we
I'm
get all the other-
just gonna go straight into answer. I'm just going with questions.
Questions? Alright.
No, what was he saying? Like,
Alright, let's do that afterwards. Can you move
Let's
ahead?
go to the next
Let's go to the
slide.
next
We
slide.
can ask this later on after the, we're all here.
For sure it was.
Oh,
Yeah, I didn't put that, but anyways, in computer engineering, simple terms, computer science is hardware, software, and computer engineering is hardware. Like, that's the easiest way to put it across. There is a difference between electrical and computer engineering again, where in electrical, computer engineering is like an engineering major for like people who don't like math. I don't like math, so I don't want to do electrical, I don't want to do signals and systems, I don't want to do calculus. So you take up this and you design computers like me. So quite a few important things that you would actually do in computer engineering would be embedded systems, which is pretty much what you're working with right now, writing software for Arduinos, Raspberry Pis, ESP8266s, IoT particle, all that falls under computer engineering. And also another important aspect of this would be VLSI, which is very large scale integration. That's basically designing your computer CPU, ICs, it kind of like figures out how to fit like billions of transistors into like a silicon die of which is 1 centimeter by 1 centimeter. And it's just completely focused on the hardware architecture of computers. Really, like, it kind of touches up on robotics, but that again is kind of a mix between electronics and mechanical that falls into mechatronics. But pretty much everything, this is computer engineering. Like, the software is not, the hardware is. That's the easiest way to put it across. Yeah, that's up for me.
Alright, remember to send
Yes,
questions
sir.
to the end. Unless it's well into it.
Well, I think it makes more sense to do it now. Just
Okay.
make them really quick.
Yeah, let's have questions, quick.
So is there like some kind of field where it's like mixing the whole software and the hardware kind of together, along with like the whole electrical to put all this stuff kind of together?
Right, so that again falls under embedded systems, but it's not like really completely into software, and neither is it completely into hardware, because you kind of have to have a mix of both skills, like software and hardware skills, to put together a robot. But again, mechatronics kind of like deals completely into that depth, and it's like a separate branch of engineering as well. Like some schools also offer robotics as a master's degree, so that could be an option for people who are interested in that. Yeah.
So I'm studying biomedical engineering, which is a smaller subset of engineering. It's a slightly more newer field. You take all the same engineering classes. You'll do calculus, you'll do signals and systems, you'll take statics, mechanics, circuits. But on top of those classes, you're also going to take more biology, more chemistry. You'll do things like systems phys, genetics classes. And your design classes will focus more on medical devices or diagnostics. You might be programming an app that could diagnose Parkinson's from something in the sole of your shoe by pace. So you learn software engineering, you learn all of these things, but it's all targeted towards medical devices. So these are some cool things that medical devices is used for. It really focuses on imaging, prosthetics, implants, biomaterials, anything used for diagnostics or in the medical field. This was a person who came to talk at my school. They designed, it's marketed as an operating room in a backpack. So it's something you could like take to like a natural disaster, and you could set it up and use it as a sterile field. Anyone know what this is? Yeah, exactly. So medical imaging has gotten extremely advanced in the past couple of years, and it's continuing to advance. And a lot of that is biomedical engineers. Prosthetics too. They're creating bionic limbs, basically. Yeah, so that's the biomedical field. Yeah.
So one form of engineering that wasn't mentioned that I'm assuming is closest to you. What about chemical engineering?
Okay, yeah, chemical engineering is actually not as close to to biomedical as you would think. Basically, the difference between a chemistry degree and a chemical engineering degree is that chemical engineers are more concerned with how those processes work and how to make them work better. So chemical engineers are actually probably closest to more like nuclear and petroleum engineers, I'd say. Not as close to biomedical as you would think. I wish we had one here, but I don't think we do.
Most chemical engineers you'll kind of see will go and work into, petroleum fields or nuclear fields. That's a huge, huge area that they'll typically go into, or obviously research.
Anyone else?
Again, it's me.
Let's go.
Like I mentioned, I didn't start my degree in mechanical engineering until I finished this degree in nano engineering. It's more or less a very, very, very small field, although the applications can cross over to biomedical, definitely electrical, and a whole bunch of these other fields. Nano engineering mainly deals with, well, obviously, as the name says, the engineering of nanoparticles at the sub 100 nanometer scale. I included a picture here of, don't know what it is, it could be gold, but some of the features that arise when dealing with nanoparticles is that based on their size, their atomic size, we can change the band gap, which is what's happening here. So when there's electrons that go from one energy state to another, they emit some type of different light, and this is just under UV light. Like I said, nano engineering is very interdisciplinary. It's got applications in fabrics, commerce, bioengineering, defense security, optical engineering, medicine, big one's medicine and drugs, and in energy. I won't really go into the specifics since we're kind of running out of time. Does anyone have any questions about this field? I can also talk about my work after I finished this degree. I was in the industry doing surface science for 3 years, so if anyone's interested, either now or for another lecture, just let me know and we can work something out. Questions?
He's also here every day.
Yes, I'm
Yeah, Bardo. Baby.
Yes, that's all we have.
Asher.
You can kind of spill over to this as well.
I think I'm too hard to move out.
Alright. Well, Roster's back there too. He's also doing
Yeah.
So what I would say about electrical is I think the cool point, especially in the modern day, is that electrical is kind of a really cool starting point for literally any other industry. So everything that all of these other guys have talked about, like mechatronics, a lot of computer engineering stuff, a lot of biomed stuff, you could go into as an electrical engineer. So you're learning the basics on how to deal with circuitry, which at this point is pretty much in everything. There's like, I remember we were doing a study in one of our classes on purely mechanical devices that still exist, and it's virtually nothing. Almost everything has kind of implemented some kind of circuit design into it. So that is what electrical engineering is really about on the very basic level, is kind of how do we design these circuits to be the most efficient, using that V equals IR in all of those techniques that you guys have been using and applying them to everything else that kind of exists in the world. And so there's a lot of different ways that we can actually do that. So the thing that I did in college was doing a signals and systems kind of route. That was studying how signals flow, how we're able to use some of those things to do certain, like if we're using a lot of like communication buses for a lot of your things, and even doing like radio waves and Bluetooth and transferring information in different ways. A lot of that is electrical engineering. How are we actually like working with these circuits to do physical things based on, I might do something in my software, do something in my firmware, but what is it changing physically? And then also you're really doing the same exact thing for going from like a mechatronics perspective. How are these moving motors? How do these certain things work? Going into a biomedical field, how do I took a quick class in doing some like brainwave scans and being able to control things using brainwaves, and a lot of that is electrical engineering in addition to biomedical engineering. I'm personally going into aerospace. I'm using my electrical engineering degree to do that, and the cool thing about this, as I said, is that it's really just a starting point for anything else that you want to do. I realized that was a really quick spiel, but that's kind of the basics.
Also, so I'm a person who's changed from computer, I was in electrical before and I've changed to computer engineering, so that kind of resonates the point that he said that you can start with electrical and kind of spill over into anything you want.
Anything?
Okay. you don't really need to bend your head if you so basically what I'm trying to add would be that is really true that the electrical engineering is really the foundation of everything else here mentioned, because for example the CS is popular, as you can see. They all run all kinds of code or software on top of the either the regular PC, your laptop on the hand, or the server in the server form. But deep down inside, all the chips or the interconnect, they are due by the electrical engineering. So we are the provider of the device, actual device itself. So that is down to the basic level. If you want to search for the root to the absolute upstream, electrical engineering should be your choice. So, and also, I'll say you can be a decent programmer if you go to CS or something. But if you want to grasp the whole picture, I'm not saying you should take the EE instead of CS, but sorry about that. But you should have more of a overall picture of how this whole system design works. For example, personally, I'm interested in robotics, and one of my focus would be the SLAM. It's called the simultaneous localization and mapping. It's used in the autonomous vehicle or the cleaning robot or something. This kind of thing actually belongs to the computer vision. Computer vision typically belongs to the computer science, of course. But to fully understand how that works and to eliminate the noise you get, you need to understand how the device works. How's the LiDAR, which is the light version of radar, why it captures different noise during the measurement, and when it's gonna detect the obstacle or when it's not. So you try to estimate that probability to avoid collision for the autonomous vehicle. So these kind of things, deep down inside, you need to have a high-level grasp of electrical engineering. You need to know how it works so you can actually operate it in software level. That is what I'm trying to add.
The other thing I'll just say really quickly is that a lot of my engineering friends in college were super jealous of me because I could use my material right away. Like freshman year, I was building projects with the stuff that I learned in class, which for the majority of engineering majors, you can't do that. Like the kind of stuff that you're doing as a mechanical engineer is not using, there's a lot of stuff where you go work for a company and you're not going to have you do actual work for a while because you need kind of that master's levels work. Electrical engineering, there's stuff, you guys are doing electrical engineering right now without actually having a degree in it, which I think is really cool because it really is operating within it's how the lights turn on, it's how you get radio in your car, it's how your phone works, it's how all these things kind of are operating around you in the real world. And because of that, you can kind of take these concepts and apply them to real world things right away just from really basic knowledge. And obviously there's a lot more advanced things that you can do with it, you're not going to be designing computer chips today. But I just think that the ability to use this information and the knowledge that you gain right away is something that's super cool.